So we'll start with the quiz now. Mr. Kustas has already put the answers in the chat window. So let us compare. So first one, what is the answer? Sorry, what did you say? One is B.
Yes.
Yeah. Reduce workplace incident and incidents. Next.
So I put B.
Yeah. Functional goals include?
A.
These are all sales turnover, profitability, market share. Are these functional means departmental? Are these departmental goals or management goals?
These are management goals.
These are management goals. So our
None
answer
of the
will
above.
be none of the above.
So D, eh?
Okay, fourth,
All of the above.
all of the above. This is cross-functional, involves all the teams. All
D.
these are cross-functional. Yeah. These are
5 is also D.
the,
All
this
of
is
the
all of
above.
the above. Okay, sixth one,
B.
B, right.
B. Yes.
Seventh,
B.
B.
yeah. No, read it, check it again.
Second option is correct.
D, yeah, D is right.
B.
Customer, first thing is customer satisfaction. Even in Six Sigma, whether or quality management, first goal is customer satisfaction. Second is improve our productivity and profits. Purpose of a quality audit?
8 is also B.
B.
Right.
9. C.
Yeah.
B.
B.
Timely delivery leading to more customer satisfaction. Fine. Very good. Okay. So now we will. Anybody, any question on yesterday's discussion?
For me, no questions. Thank you.
So most important thing we have learned yesterday is about the CTPs. We said that Y is the dependent variable, which depends on number of X's. I am on page 30 right now. And these X's are independent variables. They are the inputs and controllable factors. So the vital few, the few X's which are very important, we call those as the vital few X's, which have major impact on the Y. These are the CTPs. So to achieve CTQ, we have to focus on improving performance of the CTPs. Yesterday we did one exercise of CTQ and CTPs. Now, can someone explain what is this difference of, we discussed it yesterday, effectiveness of process and efficiency of process as defined in Six Sigma. So I'm not going by the Peter Drucker's definition, but as defined in Six Sigma.
Yeah, we said that effectiveness of the process is to increase the satisfaction of the customer.
Right, yeah.
And efficiency is to achieve the objectives by using reduced resources.
So getting more result with less resources.
Yes.
That is the efficiency of the process. And then we have explained here the how we will focus on improving the CTPs using the techniques like benchmarking and root cause analysis.
Yes.
And
we need yes.
Sorry, go ahead.
We need to find the most important, the most critical CTPs and focus our analysis on these critical CTPs.
So improve the CTPs, whereby we can achieve our CTQs. And what is this importance of the process owner? Why the project must have a process owner?
The gentleman is actually setting the objectives, and he's he's accountable for the development of the project, the Six Sigma, and he's accountable to the management also, to the top management.
So someone has to be responsible for
Yes.
achieving the CTQs, the goal statement, and that someone is called as the process owner. What is the other name for process owner? Also
Champion.
called
Champion.
champion,
Yes.
and also called as champion is used, and also another word in which is used is sponsor. So all three.
Excuse me?
Sponsor. Sorry.
Can you repeat the names? And how do you call?
Sponsor, process owner, champion.
Sponsor. Okay, sponsor. Okay, yes, sponsor. Yes.
Sponsor, process owner, champion. These are all terminologies for the process owner. Usually the head of the department who is responsible for the improvement. Then yesterday we have also seen how to calculate the sigma level of a process. So we have seen the DPU, DPMO, and then we learned how to use the DPMO table and calculated the sigma level. This example also we discussed. What is the use of doing the calculating sigma level? We can compare the various processes and sub-processes on a common scale. As I gave you the example, like the euro currency. So when you travel in Europe, you use the same currency in 17 countries. You don't have to exchange. If you travel from Italy to France, France to Germany, you don't have to change the currency. The same euro currency you can use in 17 countries. So same way, here, all the departments, we can compare the quality on one common scale, and that scale is our sigma level scale. Here also we have given an example. So let us say you are comparing, on page 36, you are comparing the performance of different departments in terms of the sigma level. The sigma level is shown on in the last column for different departments like purchase, stores, production, maintenance, logistics, technical services, finance, marketing, HR, R&D. So according to this, if you are the top management, which two processes will be our first area of focus for improvement according to this sigma level calculation? Here we are comparing different processes within the organization.
It should be production and logistic.
Okay, what is your logic? There has to
Because
be some
production,
logic in selecting the processes. What would be the logic?
I selected because of one is the opportunity of error is high, and also
See, the logic will be
CTQ.
the processes where the sigma level is lower. More improvement is required in those processes. That means the quality there is comparatively not as good. So now here, which are the processes where the sigma level is comparatively lower? You will find technical services with 3.72. Compared to others, the sigma level is low. And here you will see HR 3.83. Maybe also we can look at R&D 4.21. So on a comparative scale, these three processes will require more improvement. So if the management has to decide what projects to take up, so they will look at this calculation of the data for each department, and based on the sigma levels of the processes in each department, we can decide wherever the sigma level is low, the urgency for sigma improvement is more. So we can decide on choosing those departments for implementing the Six Sigma improvement projects. This is clear?
Yes, may I ask one question?
Sorry?
Can I ask one question?
Sure,
Can
sure,
I ask?
sure.
Yes. We said before, to calculate the DPMO, we need the opportunities for defects.
Yeah.
This one, because maybe someone in organization-wide, maybe someone can say that it is subjective. Who is calculating the opportunities for a defect?
This is done by the project team.
Hmm.
And there are 2-3 things here. I know what is your concern, but what happens here is firstly, there is a rule when we are doing these opportunities for error. So you read here on page 34.
Hmm.
So
Thank you, yes.
is for error. The opportunities for error are the total number of chances per unit to have a defect. But now, important word here is every opportunity must be independent of the other opportunities. What does it mean? You cannot duplicate. When you are making this list of opportunities for error, so let us say you say inaccuracy in the readings, and then you say inaccurate observations. That is the same actually, only we are changing the word. So we cannot duplicate. So when you are listing these opportunities for error, you will list each one independent of the other. That means if there is a duplication, so you will not go very wrong. Secondly, the sigma level calculation which we do, whatever opportunities we take before the improvement, after improvement also we will take the same number of opportunities, so that we can have an apple to apple comparison. Even though it is possible that after process improvement, the opportunities for error have gone down, let us say from 13 to 9, but we will still take it as 13 at the end of the project because that is where we started. So we will not reduce the opportunities for error. Next project, we will take it as 9 opportunities for error. So these 2 precautions we have to take. Then we will not go wrong. I hope that answers your question.
Yes, thank you.
Okay. So now we will go to chapter 6. This is cost of poor quality and cost of good quality. So what is cost of poor quality? Cost of poor quality is, so basically there are 2 broad categories of cost of quality. One is the cost of defects, failures. The other is the cost of preventing the failures. So cost of poor quality will include failure cost. That means now failure cost can be 2 types. It can happen within the organization or it can be known to the outside world. So if the defect is captured within the organization, we say it is internal failure cost. If the defect is captured after it goes to the outside world, then it becomes an external failure cost. Which cost will be higher? Internal defect captured within the organization or defect gone out of the organization?
The
Out of the organization.
external, because customer satisfaction is
External.
What goes to the outside world? So you will remember one example, Samsung Galaxy Note 7. About 4-5 years ago, there was a problem with their battery and the battery used to burst. So the problem became so big that even the airlines banned. They said you cannot carry this Galaxy Note 7 in your checked baggage, it will have to go in your hand baggage. So that if the battery bursts, it will happen inside the bag in the cabin, not in the luggage area, it could cause a fire. So this became such a big problem. So when the failure is external, when it goes outside the organization, the failure cost is more. Why? Because when there is a failure, there are two costs. One is the direct cost, the other is the hidden cost. So what is the hidden cost? Hidden cost is loss of goodwill, loss of image, loss of customer confidence. That is hidden cost. And the direct cost is the internal failure and external failure cost. So which cost will be more? The external failure cost, because the hidden cost will be more. Always our effort will be first to minimize the external failure cost, reduce it, then we will focus on reducing the internal failure cost. Internal failure cost happens within the organization. External failure cost is going outside the organization. So you will recall one more example. This Volkswagen, some 4-5 years ago, they had to recall a large number of their cars for repair of the catalytic converter. Now, why they had to do this? Because they had juggled, they played around with the pollution control software. So they were giving a certificate that the car is meeting the pollution control requirements, but actually it was not meeting the requirements. So using the software, they're giving a wrong certificate. And at some point of time, this became known to the world. The result was they had to pay a huge penalty to the governments in many countries because this was detected, and also they had to replace the parts in these cars. Recall, a huge loss for the company. So whenever the failure is outside the organization, the failure cost is very high. So that is, first our effort should be to minimize the failures which go outside the organization. Then we will focus on minimizing the failures which happen within the organization. This is clear?
Clear.
Okay. Now, the other type of cost is called as cost of good quality. So what do we mean by cost of good quality? Cost of good quality is the amount we spend to ensure good quality. So for example, we spend money on inspection, testing, auditing. All these go under the cost of appraisal. So why do we do this? So that the defects should not go outside the organization. And the other cost of good quality is cost of prevention. So what we invest on POCA-YOKE. So whatever RCO or ICD prevention we will add, which you learned yesterday, that will prevent the defect. So that is also called as cost of good quality. So here we have got examples, comparison of cost of poor quality and cost of good quality. So cost of poor quality is cost because of defects, errors, failure in the product or service. Cost of good quality is cost incurred to ensure processes and outputs are meeting the quality standards. Okay, I will ask you one question. Some of you are from the construction area. So at many construction sites, when they make the buildings, they are creating the blocks. They, instead of the bricks, they manufacture the blocks at the construction site and use these in the construction. Is that right?
Sometimes.
Yeah. So what is the prevention or inspection that they're doing in this? So normally my experience is that they may be destroying one block for every 1000. We call it as a destructive testing. So they will damage one block out of 1000 blocks just to cross check what is the strength of the block. And if one batch, even one block is found weak, then that batch they will reject. So that is a cost of prevention. It's a destructive testing, cost of prevention.
Yes.
That's okay. Is that right?
Yes, correct.
Okay. And same way you have audit, inspection, testing at the site. So all this is also cost of preventing the defects through inspection so that they don't go to the end customer. So these are called as cost of good quality, and the defects which go to the end customer, those are called as the cost of poor quality. So here we have given some examples. Cost of poor quality is rework and scrap, warranty claims, penalties and legal claims, loss of customer trust, carrying more inventory because of defects. These are examples of cost of poor quality. Cost of good quality is training the people so that they don't make defects. Supplier quality, auditing the supplier quality, evaluating the supplier, making improvements in the process design, and testing, inspection of products. So this is all cost of good quality. So if you see this example here, this is the iceberg. Even in a glass of water, if you will put ice, you will find 80% of it is below the water and 20% is visible on the top. So the failure costs, only 20% you can see. 80% of that is hidden in the water. This is the iceberg example, or the ice cube in the glass. These are also examples of hidden costs. What you see below, those are the hidden costs, and above is the visible cost. Those are the what you can see directly as internal and external failures. So here is one exercise for you. So we have in the first column, we have nature of cost, cost of internal failure, cost of external failure, appraisal cost. They are the figures for year 1. Now in year 2, what the company has done, they have appointed one additional inspector. What is his job? To check the outgoing quality. So from January, 1st January of year 2, this inspector was appointed so that he will not allow defects to go out of the organization. Now you have to see these figures, check the calculations and give your comments. You have to answer 2 questions. First, in terms of total cost of quality, which is a better year, year 1 or year 2? And second question is, what will be your plan of action for next year? So just do your calculations and tell me. If we add this total cost of quality in the year 1, this is
760,000.
160K. That is right. And
The other is 800.
Now, what do you say, which is a better year and why? In terms of total cost of quality.
Better year is year one because the internal failure was very, very big in year two, very big. They reduced the reduction in the cost of external failure occurred in year two. It was less than the cost of internal failure.
Yeah, but which is better, external failure cost or external internal failure?
Okay, yes, as evaluation is year second is better because the external failure is far less than year one. But still they need to do prevention because year two also very expensive in general, in total.
Year two is expensive because we have added one more inspector. If you notice,
Yes.
Additional inspector has been added. So appraisal cost has gone up from 210K to 310K. But what is the impact?
Because of reduction in the external failure.
There is a sharp reduction in this external failure cost. And external failure cost, as you know, there is hidden cost also.
Yes.
External failure cost, you are also saving the hidden cost. That's a very good sign that has happened because of this additional inspector. But our total cost of quality has gone up because of his salary. Now the question is, why the internal failure cost has gone up?
Because the inspector gave additional comments for defects.
Yeah, so this inspector does not allow the defects to go out.
Yes.
So because he is not allowing the defects to go out, these defects are now becoming an internal failure cost. So this cost has gone up. Now next year, this information, these defects which have been caught, the defects which have gone outside, which would have gone outside, he has not allowed them to go out. So as an inspector, he has played the role of a watchman. He is not allowed the defects to leave the organization. So because of that, internal failure cost has gone up. So can we see this as an opportunity?
Yes, definitely, yes.
So what is the opportunity?
Prevention.
Because these defects are captured within the organization,
yes,
they can do an analysis, find the root causes, and then what you're saying is right, they can start spending on prevention. So what have we done? First, we have increased our cost of inspection, which will help us to catch the defects. Once we catch the defects, we can do the root cause analysis, build the POCA-YOK. That means our cost of prevention will increase, but next year, our internal failure cost will also go down and external failure cost has already gone down. That will be our strategy for the next year.
And if, sir, and if they maintain the improvements after the POCA-YOK, it will be everything better.
Yes. And all these costs will go down.
Yes.
So total cost of quality next year will become less.
Yes.
If you see this picture on page 41, this is the cost before implementing Six Sigma, and this is the cost after implementing Six Sigma. What is the difference?
Very big, yes.
Here we are spending very little on prevention. We are spending more on appraisal failure, appraisal cost, internal failure cost, external failure cost. Now what we have done, we have increased the cost of prevention. The cost of prevention earlier was only this much. Now cost of prevention has become much bigger. But because of that, our cost of inspection has gone down, internal failure cost has gone down, external failure cost has gone down. So this benefit, what you see, this is our saving because of the Six Sigma project. This is the reduction in our cost of quality, cost of poor quality, and this is our saving. We have spent more and more on prevention. The net result is we are achieving much more reduction in internal failure, external failure, and even when you spend more on prevention, the inspection cost will also go down. So our main cost will now be cost of prevention. So this is a study which was done by one American expert by the name of Phil Crosby. So he has calculated for an organization, for various organizations, the ratio cost of quality to sales. You can do it for your organization also. Take up all the major costs and calculate cost of quality to sales. And he found that when the sigma level of the organization is very low, let's say we are at 1 sigma, our defects are nearly 69%, as I showed you yesterday, and the cost of poor quality, cost of quality as a percentage of sales is somewhere here around 40%. When we reach 3 sigma, this cost of quality as a percentage of sale will become around 15%. And when we reach 6 sigma, this cost of quality as a percentage of sale will be around 5%. In fact, sometimes it will go even lower. It may be about 2 to 3%. So this is the reason why organizations are implementing Lean Six Sigma in the organization, because this is helping them to bring down the cost of poor quality by increasing cost of prevention. You reduce cost of inspection, cost of internal failure, cost of external failure, and hidden costs. So all the other costs will go down, and main cost will be cost of prevention. Of course, if you reduce the prevention, again your cost of poor quality will increase.
So, sir,
Yeah.
so Six Sigma is very important because Six Sigma is 5% also the cost of quality only.
So you think
the
of it,
sales.
let us say your project, how much your cost of the project can go down. I mean, if you can cut down your cost of poor quality, you can achieve good savings in your project implementation.
Yes, yes.
That is exactly how it is. We had done some projects, Riyaz is aware about it, for King Fahad Causeway Authority. You know, they are the authority who manages the Bahrain and Dammam, that across the bridge, the entire of that process.
Yes.
And they have a lot of construction work by the contractors and so on. So we did 2 Six Sigma projects, we guided them, and they achieved very good savings as a result of the Six Sigma implementation. So what your observation is right, that actually when you implement Six Sigma, your defects will go down, failures will go down, savings will increase, customers are happy and are happier, and management is also happier. Very important point. So this is a small chapter. I will quickly talk about it. This is history of Motorola, why they thought of Six Sigma. So when Motorola in the 1980s, they were facing a lot of competition from Japanese companies in the field of electronics, just like the automobile companies were facing a lot of the competition from Toyota. So at that time, Motorola's profits had declined and they had reached here what is called as valley of death. I gave you an example yesterday of Kodak and Nokia. They did not take action, and you know they have gone down tremendously. However, Motorola took action. They went for Six Sigma implementation, and that helped them to grow their profits again. So this was the reason why Motorola thought of Six Sigma. Actually, they were in a bad situation. If they had not done, they would have also been on the route of Kodak and Nokia. So if you see yesterday I've shown you this table, the defect percentage at 1 sigma, I told you that is 69%, 2 sigma is around 31%, 3 sigma is 6.6%, 4 sigma is 0.62%. And so if you see the improvement, when you go from 1 sigma to 2 sigma, the defects will reduce from 69% to 31%. That is a 2 times improvement. 2 to 3 sigma, the defects will go down from 31 to 6.6. That is a 5 times improvement. 4 sigma, 6.6% to 0.6%. That is a 10 times improvement. The real challenge is when you want to go to 5 sigma and 6 sigma. At 5 sigma, we are talking of reducing the defects to 0.023%. That means 0.62 divided by 0.023. That is a 30 times improvement. And 6 sigma is 230 divided by 3.4. So this 0.00034%, this is a 80 times improvement for the organization. So this is how Motorola achieved the Six Sigma level. How many years did they take? They took 8 years to reach the Six Sigma level. So in 96, their DPMO was 30,000 as a company. They said we will reduce our DPMO by 10 times every 2 years. That means 86 to 88, they will go to 3,000, 30,000 to 3,000. Next 2 years, 3,000 to 300. Next 2 years, 300 to 30. And next 2 years, they said we'll go to 3. So that was their target, and that is how they achieved. Actually, they took 8 years to reach Six Sigma. So what I want you to understand is that Six Sigma is a very high target. It is not an easy target, and it requires a lot of self-discipline and efforts to do the Six Sigma implementation. So these were some of the actions taken by Motorola. Most important was they spent a lot on training of the employees and suppliers. Why it is important to train the suppliers? Because suppliers are giving us the inputs. If their quality will improve, our quality will improve. They also started a Motorola University to implement Six Sigma. So there are different areas in which they provided the training. They went for benchmarking on a global scale. What does this mean? What is the meaning of this? Benchmarking on a global scale?
To be the best in a global market.
Exactly. So they looked around all over the world to learn lessons from the best performers. And they also introduced a culture of total customer satisfaction within the organization. That means employees have to work for total satisfaction of the customer. Because earlier, there used to be a trend that if the customer will complain, the customer will be blamed. People will tell the customer, you are not using the product properly. Even now, it happens sometimes. You go to you bought a new mobile, you give a complaint. The first answer they will give you is that you are not using the product properly. Even within the organization, you have a problem with IT, you have a problem with maintenance. If you will complain, first reaction of the internal supplier is you're not using it properly. So they have to be convinced. So actually, Motorola changed the culture. They said when there's a customer complaint, we must study the complaint and go into the root causes and remove the complaint. We should believe the customer instead of challenging the customer. So that was the total customer satisfaction program. It was called as the TCS program. So we will, in a few minutes, we will take the prayer break. But before that, I will give you one reading homework. This chapter 8, cultural changes required while implementing Lean Six Sigma. So this is a self-reading. You have to read this, and next week when we meet, we will discuss this section. The most important part in this chapter is the 8.2. So what is this 8.2? Cultural changes required while implementing Lean Six Sigma. So when you are implementing Six Sigma, it is not only the technical tools, but remember that improvements, ultimately processes have to be driven by the people. So you have to change the thinking of the people. So cultural change is very important. And this 8 points are there. Please read this. We will discuss this next week. I am giving you one more homework for next week right away. So you go to page. This is a bigger article for reading, but I'm sure this will be useful to all of you because you are in the area of process excellence, and this will help you to understand how today AI, normally people think that AI is for content writing and advertising. Yeah, that is right. But AI also has lot of applications in the field of quality management. So this is an article is little long, but I'm giving it to you today because you have got a full week ahead of you. We will discuss this on next Friday. You have to read this before you come for the class. Now this is on page 181. AI-enabled LSS Lean Six Sigma implementation. So one I have told you is chapter 8. I think that is on page 45. Page 45. That is a small, four pages. This one is little longer. You have to read this. This is AI-enabled Lean Six Sigma implementation. You read this, there are certain tools of Six Sigma, AI, which are explained here, how you can use these. And then some use cases are there, practical examples, which I will share with you. I will just explain you right now. The practical examples are, they are called as use cases. And here, PPE detection in working areas. For example, in large construction areas, let's say you are doing an airport construction where total area of the construction is spread over, say, 20 kilometers. So many times the operators, they may not be supervised all the time. So sometimes they may not use the PPE and they may land into safety issues. So using AI with vision cameras, how we can detect and record the non-use of PPE by the workers. So this is one use case. Each one of you can read one of the use cases. whichever likes you like. If you also read the same use case, no problem. So this is PPE detection and working areas. Then another use case is this is equipment failure in hospitals. So what happens is that in hospitals, there are beds, stretchers, and machineries which are spread out over a vast area. So how do you monitor the health of these equipment? For that, we can use the AI in healthcare, in hospitals. Then the third example is energy management. How through the real-time monitoring and data analysis, we can use AI for the energy management in the organization. So you can save energy and bring down your power consumption. And this is a practical example, the fourth one, which is inspection in jewelry manufacturing. So jewelry manufacturing is a very precision engineering where they have to make small parts. They have to put something like maybe 15 diamonds in a small ring. So it's a very accurate activity. And the inspection can sometimes be very tedious. So here also you can use also same way the demand forecasting. How do you forecast the demand of the products? How do you do inspection of the products? So all this is explained here for the jewelry industry. And this section 12.3 is overall, this applies to all of you, unlocking the power of AI in quality control. So in quality control, how you can use AI to reduce your, the defects which escape attention. This helps us to catch the defects faster. So this is a summary of that section 12.3 in the form of a table. So you give an example like automotive, what techniques you can use, what are the benefits, electronics, food and beverage, FMCG, jewelry, pharmaceuticals. So these are examples of use of AI in quality control. So there are many applications, and you read this, we will discuss in the class next time. This is from page 181 to 200. This is 20 pages. It's a long reading. So I'm giving it to you today because in the week, what you can do, you can read. Don't read all 20 pages on one day. I will suggest you can read about 4 pages every day. And if you want, even this pages, you can, this PDF part from 181 to 200, you can paste it in ChatGPT or in Gemini and ask for a translation. You will get a translated version to Arabic. And then you can read the Arabic version also. So maybe some of you will find that more useful. So we'll take a break now for 20 minutes and then we will continue. Okay. So we will continue now. So we have covered these first 6 chapters in our discussions, 7 chapters up till here. And this 8th chapter, this I've given you for reading as a homework. We are now moving into the Six Sigma tools and methodologies. We'll now go to chapter, this is all technical matters, chapter 9, 10, and 11. The statistical tools, other tools, and then we will go into 12, that is DMAC methodology, SME, that is risk assessment methodology, as we proceed further with the course. And our last 2 sessions are going to be on lean management. So this is the remaining portion which we have to cover. So we will go to chapter 9, that is understanding variation. And we will be using the Excel sheets that I've been using with you already for doing some exercises. Now here, there are, chapter 9 is on the subject of understanding variation in processes. Chapter 10 is on 7 tools of quality. So today I will start with you with chapter 10, because this is the heart of the program. So I am doing it now so that during the week you get a chance to revise. So these are 7 tools of quality in chapter 9. We'll cover these and you revise during the week. When you come back, these are in chapter 10. When you come back next week, then we will do this chapter 9, 11, 12, and so on. And this other reading I have given you is here. This AI-enabled LSS implementation, Lean Six Sigma implementation and use cases, page 181. This is the other reading homework I have given you. So let's go to page 55. The 7 tools of quality play a very important role for data analysis. And to find the improvement solutions in Six Sigma projects, these tools are very useful. The 7 tools are, first is flowchart and process map. This is a non-statistical tool. Then second is check sheet. This is database, statistical. Third is Pareto chart. That is again statistical, database. Then histogram, that is also database, statistical. Then fifth is fishbone diagram. Some of you must be knowing already. It is also called as cause and effect diagram and Ishikawa diagram. This is again non-statistical. This is a brainstorming tool. Scatter diagram. This is also statistical tool. And control chart. That is also statistical. So out of these 7 tools, 2 are non-statistical, that is flowchart, process map, and remaining 5 are database. Purpose of these tools is to present the data in a visual manner. So we present the data in a visual manner, which can be then used for analysis by the cross-functional team. Now, the first tool is flowchart and process map. Flowchart and process map are similar but not same. Flowchart relates to the steps in a proper sequence for a particular task or a particular person. Flowchart is also showing the steps, but it is also showing how the process moves from one department to another, one level to another. Analysis of flowchart and process map is similar. So how will you analyze the flowchart and process map? There are three things you will do. Firstly, what are the critical process points? Now, what do we mean by critical process points? So, critical process points are those points in the process where we need to take extra care. That means you need to have more inspection, that is appraisal, and more prevention, that is RCO ICD. Because critical control point or critical process point is where the defects can happen and delays can happen. Can you give me an example from your construction projects? In the construction project, what could be example of a critical process point?
The material receiving.
If the material is not received on time, what will happen?
Will delay.
So everything will be disturbed.
Yes, and also the quality. If we receive material of the non-compliant with the requirements, also we will have problem during the construction, the installation.
Absolutely right. So these are the critical points in the process where, because of which defects can occur and delays can occur. So we need to prevent these using RCO ICD. Very important. Now, the second study of the process map is to look for missing steps. What are the missing steps? That means in the process, maybe some important step has not been considered. Some inspection, some checking. So we should look for that. And third is whether each step in the process is useful, whether it is adding value. So value addition provided by every step in the process. So here we will look at one small exercise. Let us say you have given your car for repair in the garage, and here the steps of the process map are shown. So you bring your car for repair, then estimate is prepared. As an owner, you give authorization. You leave the garage, then car is inspected by technician. After he checks, he makes another report, supplementary report, and sends you it by WhatsApp or email. Then he asks you to approve that estimate. So this is step 1, step 2, step 3, step 4, step 5. So first you analyze up till here and tell me how we can improve this process map. What is wrong with it? Hmm? Mhm. So,
Here the estimate is prepared as step 2, which should be done later.
okay, why?
Because the estimate should not be prepared before the inspection.
Right. So this step, making an estimate, asking the owner to approve, these are not adding value. We should remove these steps. So our process should start here. This should be our first step. Car is inspected by technician. Report is written, not a supplement report, but just a report. That will be the second step. And this report will be approved. That will be the third step. First two steps we will remove. So in the process, these are not adding any value. Only they are wasting time for the customer and ourselves. Now the next step is estimate completion date. Now before giving this estimate, is there any missing step here? For giving completion date, should
To
give any
put the parts order the parts
So for that,
before
what is required?
before give the completion date to have all the parts available. I don't know.
Okay. So first you have to check availability.
Yes.
So here you have to check availability of the parts. If they are available, then we can give an estimate of the completion date and parts ordered. So then this is okay. The missing step. Now parts are delivered and the vehicle is repaired. Any missing step here?
To verify correct the material receipt, to verify that correct
Quality,
parts are delivered.
yeah, parts functionality, if it's working or not.
To check the parts before doing the repair. Otherwise, what will happen?
Maybe failure in the repair.
Yeah, so it will lead to rework.
Yes,
So check
rework.
the parts before fitting them. So one more inspection is missing here. So one inspection was missing here, availability of parts. Second inspection is missing here. Check the parts before using. What is missing here?
Final quality control.
Right. So a test drive
Yes.
by the garage people before they tell the customer that car will be ready at this time and on this day.
Okay.
So this is again a missing step. So inspection here, inspection here. Then after this, they can give the test drive and hand over the car. That is okay. So this is how we can analyze the process map to see where the missing steps are there, where non-value adding steps are there, like the first two, and where we need to add prevention in the processes. So this is the purpose of the flow chart and process map. Any question on this?
No question, no question.
Okay. Now the second tool is very simple. This is basically a data collection device. I'll just show you. Give me a moment. This is called as a check sheet. This is different from checklist. A lot of people mix up these two words. This is called as a check sheet. What is the check sheet? Purpose of the check sheet is to count the occurrences. So what we do is let us say here we are doing some data collection regarding answering of calls, and these are the reasons, the defects which can happen. The wrong number, wrong information, connecting to wrong boss. So we can use these marks. They are called as tally marks to count the occurrences. So normally you would have used this sometime in college. This tally marks, these are called as tally marks. So you put these in lots of 5. So let us say here you're recording data of defect 1, defect 2, defect 3, defect 4. So easy to record, easy to count, and also you can see this where the occurrence is more. Visually you can see that this defect 3 has the highest occurrence and the least is defect 4. If I rotate this looks like a bar chart. I can also rotate it and make it look like a bar chart. So these are the tools which we can use for counting the data. This is called as a check sheet. Now what is a checklist? What is the difference? So here we have a question for you. What is the difference? I know you're using checklist very often. So what is the difference between check sheet and checklist?
The check sheet is, as you said, to count the observations. The checklist is to list the requirements and check if requirements are met or not.
Yeah. So we are using checklist for what purpose?
For checking, for control.
Okay. Any other? You're right, it is used for control. It is used for checking. And any other use of checklist? Checklist can also be used to prevent the defects. When somebody is doing a job, the person can use the checklist, and this checklist will show this checklist will help him to make sure that he does not miss out any step. So if you have gone through auditing, let us say you have been audited or some auditor has been doing your auditing or you are doing an auditing, you will also use a checklist to make sure that you don't miss out any question. So why are we doing? Here we are using the checklist for prevention, so that we should not forget any question. What is the other use of the checklist? One is prevention. So other use of the checklist will be inspection. So it is used for both inspection and prevention. When someone is using checklist to do his own work, it is a prevention. When someone is using to check other person's work, it becomes a inspection. This is the second tool, which is very important. Now we'll go to the third tool. I'm sure you are aware about this tool. This is the Pareto chart. So now what is Pareto chart? Yesterday we have talked of Pareto. What do you understand by Pareto?
Is to count the most critical factors.
Yeah, so Pareto is the 80-20 rule.
Yes.
It helps us to see the 20% items which account for
80%
of the impact.
Yes.
Now, here this is an example of causes for railway accidents. So there are different causes like driver sleeping, engine fault, track fault, signal fault, and so on. So we will go to the Excel sheet. All of you please go to the Excel sheet. And in the Excel sheet, the third tab, this is Pareto railway accident. So here, can you all see my screen? I'm sharing again. This is Pareto. So railway accidents. Now what does this data show here? That out of 50 accidents, 17 happened due to driver sleeping, 12 because of engine fault, 8 because of track fault. So all the causes are listed here and the occurrences listed here. That is column I. What is column H? H is cumulative. Cumulative means you go on adding up. That means only driver sleeping leads to, now the 17 out of 50 means 34%. So here column I is the number of occurrences, column J is percentage. So 34% accidents happen because of driver sleeping, 24 because of engine fault, 16% because of track fault, 8% because of signal fault. If we add up, that becomes cumulative percentage. Cumulative percentage means driver sleeping leads to 34% accident, plus 24 leads to 58% accident, engine fault included. Then track fault 16% you add, so 74%, and signal fault 8%, so 82%. So these four causes are responsible for 82% accidents. This we would like to see in a graph. That graph is the Pareto chart. So there was a time when we used to do this manually, but nowadays this is very easy to use in Excel. So that is what we will do. I hope you have all brought your laptops, and I hope you are referring to the Excel. You have the laptops and you are referring to the Excel?
Yes, yes.
Okay, very good. So now we don't need to do all this calculation. What I showed you, number of accident, percentage, cumulative percentage, no, nothing. Just we will see this column B and C. Column B is railway accident and column C is number of occurrences. Here we have arranged highest to lowest, but that is also not required. Excel will take care of it. Let us say if you have mixed up the causes, highest, lowest is mixed up, till when you do the Pareto, you will get the proper Pareto. So now you select these two columns, B and C, railway accidents and number. All of you with me, please. Railway accidents and number. Now you go to insert. Click here on top, insert. Can you see insert?
Yes, yes.
Okay. So now in insert, you will see here this recommended charts. So you go to recommended charts, and actually here you have recommended charts and all charts. All charts also we will use. For example, we can use it for histogram and for some of the other tools. But right now we will be in recommended charts because Pareto is shown here in the last. So you will select this Pareto. Go here on the right side, click that. So we'll select the Pareto under recommended charts. We'll go here and OK this. So now we have got our Pareto chart. Now what you do after you have made this chart, you click on this plus. This is called as chart elements. Chart elements, here you will see data labels. You click on data labels, you will get the data. So what does this show? Where is the 80% in this chart? See, this left side is numbers, this right side is percentage. So you will see here, this is around 82%. That means
The signal fault.
sorry?
The signal fault.
Yeah, so signal fault. So driver sleeping, engine fault, track fault, signal fault accounts for 82% of the accidents. So you can see from the Pareto here. This helps us to do the further analysis. So any question on this?
No, no.
You can do manually, but what I've shown you in Excel, you can save a lot of time. There is one more exercise here. Go to the fifth tab. So here you have supplier rejections by value. You have supplier A, B, C, D, and column D, we have the rejection by value, and column E is the rejection in percentage. So actually, we do not need this column C. Cumulative rejection, we don't need to do. I'll move it here. What we need is this rejection by value number. So now I have this. Now all of you, can you draw the graph on your own? I will show it to you later, but you try to do it on your own. And tell me your conclusion from the Pareto chart. Have you made it?
The first four suppliers, A, B, C, D, are 80% of the failure.
Right. So, like we have done earlier, we will select these two columns, then go to insert, and in insert, we will go to recommended charts, Pareto, and OK this. This is our chart here. And we will, have you added the chart elements? The plus sign? Did you add chart elements, data labels? What does it show? As you said, these four suppliers, A, B, C, D, they are accounting for about 80% of the rejections. So if you can improve their performance, you can bring down the rejection considerably. If I add these, it is about 1800 out of the total rejection. The total rejection is 2200. These four suppliers account for 18% of the rejection. Okay, clear?
Yes.
Okay. 1 second. Huh? In the book, now we will go to the fourth tool. This is called as the histogram. Now, before we talk of the histogram, we have to understand one thing. We have to learn that the data which we are collecting, there are different types of data which we are collecting. So what are these types of data? We will try to understand. So for that, types of data, we will go to page 135. In the workbook, you have this types of data on page 135. So there are two broad categories of data. Variable data, which is also called as continuous data. This is the data which we are collecting as a measurement on a continuous scale. So for example, height of people in a room. So somebody may be, the height may be 150, someone may be 160, someone may be 190. So there is a variation from minimum to maximum. Highest minus lowest reading, we call that as the range. And we plot this data to show the number of occurrences for each range of data. So if you see this example here on the screen, this is here we are showing in a room, there are say 100 people and we have recorded their weight. Weight is also a measurement, so it's a continuous or variable data. So there's one person who weighs 50 kg, two persons 52 kg, three persons 56 kg. As you go to the middle, you will see much larger occurrence. That occurrence is the highest part of the histogram. So around middle, around 75, you will find there are many more people in the range of say 70 to 80. Many more people here. But on the lower side, say 50, there will be few. Same way, around 100, there will be few. Majority will be here in between, let us say 70 to 80. So this gives the shape to the diagram. This is called as a normal distribution curve. And it gives the shape of it's a bell shape. So this bell shape is like an inverted bell. And this bell shape, this is called as the histogram. What we are seeing in this bell shape curve is how much the data is spread out. So I will show you one example in the book. what we mean by spread out data. I will come back to this types of data on page 135, but first I will show you what we mean by histogram and what we mean by spread of the data. So we will see this on page 50, page 61. So here we have got data of marks of two schools. So here are the readings. The marks of school A and school B. So 50 students, marks obtained by the student, percentage, and we have taken 50 student sample from each school. And passing percentage is 50%. Looking at these marks, there are totally marks 50 students each in each school. Looking at these marks, what is your comment? Which is a better school? Which school is doing better? This mark is shown here and also shown on the next page. What did you say?
It seems that they have higher. The peak grade is higher, 96%.
Yeah.
The top grade.
Okay. So school A, up till here, the school A students are getting better marks compared to school B. Like this 62, this is 58, 68, this is 61. Everywhere, school A students are getting better marks than school B. But then, when you go down, you find that in school A, these 11 students are failing. Whereas in school B, everyone is passing. Generally, a parent will prefer which school? Higher marks or 100% passing?
The higher mark, I think, because the other one does not make sense. That all passing.
Okay, so maybe yeah, so the higher marks, the school with higher
seems,
marks, normally
yes,
parents would like to have the child in the school where the marks are more.
yes,
But
but
sorry?
it seems that in the school A, the distribution of the results are more logical than school B. In school B, it seems that there is a requirement that all students will pass, which is not correct, I think. It's not it does not make sense.
School B, everyone is passing.
Yes, yes.
So some parents would be happy with that. But school B, school A, top 30 students are getting more marks, lower students are getting less marks, and 11 students are failing. So some parents may not be interested. Now what can happen here is that parents, where the children are more getting better performance, they will put the children in school A, and parents where the children are little weak, they will prefer to put the children in school B. So what will happen?
Okay.
Both the schools are likely to lose business in the process. Both the schools are likely to lose business in the process. So to prevent this, we need to analyze further data of the school. So for that purpose, we draw the histogram. So what you see here on the next page, this is the histogram of school A and school B. Now school A, as you can see, the spread of the marks is more from here to here, because approximately here these students are failing in school A and they are passing with highest marks. School B, if you see that is the blue school. Blue school is the school A and pink one is school B. So if you see the pink school, the highest marks are less, but nobody is actually failing. So the spread, and also the spread of the data is called as the spread or the range. So the spread of the data is, that means variation is much less for school B compared to school A. However, the higher marks are better for school A compared to school B. So normally in these situations, we look at two things. We look at the average performance and we look at the variation. Now if you see the average is the mean. So the upper one is school A, lower one is school B. So whose average is better? School A average is better, and that we can see because 30 students are getting higher marks, remaining 11 are also failing. So average overall is better for school A. School B average is less. What about the variation? Variation is measured as range or standard deviation. So here the range is what? Highest reading minus lowest reading. Standard deviation, I will tell you next time, but standard deviation is also measuring the variation. So in this case, which school the variation is more? Which school the variation is less? So school A, the variation is more. School B, the variation is less. If you look at the standard deviation. So normally customers do not like variation. So many parents might feel that if we put our child in school B, he will have regular standardized marks. At least he will pass every time. School A, there is more variation. He might fail. So this kind of fear can happen for the school A parents. So this is how the histogram helps us to see the variation visually and also to compare the readings by comparing the range, standard deviation and the average performance. We will talk more about this with an Excel exercise in our next session. Today I will cover the other tools of quality. In the next session we will talk of this. The next tool we are talking of is the fishbone, which I'm sure those of you who have done PMP, you must have also studied the fishbone. And fishbone is also called as Ishikawa diagram. That is the Japanese person who invented this, and also cause and effect diagram. So basically fishbone is to help the people to brainstorm and put the causes under different categories. So it becomes easier to do the analysis. So how do we put the causes in the categories? These are the normal categories which are chosen. The 5 M's, that is men, materials, machine, methods, measurement, money and environment. In some cases, we can also add, maybe instead of money, we can have maintenance as a category. So like that, we can have different categories and we will do the brainstorming and the team will put the causes under the different categories. After that, they will collect the data about the occurrence, like we did for the railway accidents. How many accidents happened because of driver sleeping? How many because of engine fault and so on? And those we will make the Pareto. From there we will get the vital few causes. Pareto will give us the vital few causes. After the vital few causes, we can, for each cause, we can go for the YY analysis. For example, why does we said 34 accidents? That means 34% accidents. 17 out of 50 accidents happen because of driver sleeping. So we'll do the YY for this. Why does driver go to sleep? So we'll say, why does driver go to sleep? Because he gets tired. Why does he get tired? Because he has long hours of working. Why he has long hours of working? Because the scheduling is or planning is done in that manner. Why the planning is done in that manner? Because we don't have a system for planning. We lack a system for planning. So the people are going by their guesswork and judgment. Now, because the system of planning is not okay, the result is that wrong planning happens, and sometimes driver has to drive for longer hours, which leads to tiredness, and which leads to sleeping, which leads to accident. So like this, we can, after the fishbone, we can collect the data, do the Pareto analysis, shortlist the causes, and for each cause, we can do the YY and then add our Poka-Yoke. So what Poka-Yoke we can have in this case? First is develop a system for allocating the duty hours of the driver. So have a proper system to allot the duty hours. Another Poka-Yoke we can have is these days there is a device which can be placed opposite to the driver's eyes. It doesn't disturb him, but actually that eyes has some rays. So those rays are falling on the driver's face while he's driving the engine. And that is designed in such a way that in case while driving the engine, his eyes closed, there will be a loud alarm and he will wake up. So this is an ICD, increased chance of detection. So you can add this kind of prevention or Poka-Yoke to prevent the accidents in future. If we go back to our Excel sheet, here you will see the example of the fishbone done in an Excel format. So here we have shown something like railway accidents. Here we have shown car accidents. Analysis is similar. And instead of drawing it like this fishbone, we can put the causes here in the Excel under categories like same categories: men, material, machine, method, money, measurement, maintenance, environment. So here we can put, say, railway accident or car accidents, whatever cause, whatever effect we are studying. That we will put here whatever effect we are studying will be our car accident, and then we'll put the causes under these categories. Then those causes, as I said further, we will do the data collection, do the Pareto, then we'll do the YY, and we will add our Pokayuki. So this is how we are using the fishbone together along with the YY analysis to minimize the occurrence of the root causes. This fishbone can be done as a 5M fishbone, like I told you: man, material, machine, method, measurement, maintenance, and so on. Fishbone can also be done as a 4S fishbone. Sometimes, particularly in service business, the people change the categories. Instead of taking the categories as man, machine, material, method, maintenance, instead of that, you can take the cause as surroundings, suppliers, right, systems, skills, and systems. So these are the 4S fishbone. Technique is same, methodology is same, everything is same, but here instead of 5M, we are using 4S. Both can be used in the same way. Sixth tool that we are going to see now, this is very useful tool. This is called as the correlation diagram or the scatter diagram. What is the purpose of this tool? Find the CTPs in the process.
Mr. Singh, can you share your screen?
I am on page 63, by the way. So purpose of correlation diagram or scatter diagram is to find the CTPs in the process. So we will plot the data. I will give you an example here. Let us say we are plotting percentage productivity versus percentage attendance. In every month attendance we record and the corresponding productivity, or percentage productivity against number of holidays in a month. Now here, when you are drawing this graph, what you will put on y-axis and what you will put on x-axis. What will work on the x-axis and what we will put on the y-axis. Always dependent variable will go on y-axis, independent variable will go on x-axis. So here, what is depending on what? Productivity depends on attendance, or attendance depends on productivity?
Productivity depends on attendance. So X, Y productivity and X attendance.
Absolutely right. So productivity will go on y-axis. It depends on attendance. Attendance will go on x-axis. Same way, productivity will depend on number of holidays. So productivity will be on y-axis. Number of holidays will be on x-axis. Now, when we draw this correlation diagram, this diagram is also called as a scatter plot. The diagram is called as correlation diagram or scatter diagram. The purpose is to find the CTPs, the YQQ axes, which have major impact on the Y. So Here, when we draw the correlation diagram, we will see different situations. In some cases, when we plot the points and join with a straight line, many of the points will be on the line, the other points will be near the line. That shows a strong correlation. But now what is the difference between this diagram 1 and diagram 3?
Yes, that diagram 3 is negative, is the opposite.
Okay. So in both cases, the points are near the line. That means it is a strong correlation. But in case of first case, as the x increases, y increases.
Yes.
That is called as positive correlation.
Positive, yes.
And the points are near the line, so it is called as strong positive correlation. So for example, we might find that correlation of attendance and productivity will be strong. More attendance, more productivity, less attendance, less productivity. So this will become a strong positive correlation. Number 3, as the x is increasing, y is reducing. So this is called as negative correlation. And here again, the points are near the line. So this is a strong negative correlation. If the points are not very near the line, like you will see in this number 5 and number 4. Number 4 we will say is weak correlation and it is negative. Number 5 is moderate. Points are not very near but not very far. This is also negative. Number 2 we will say no correlation because the points are far away from the line. Weak correlation, again weak positive. And number 6 we will say no correlation. So you can't draw any kind of straight line between the points. So there is no correlation in number 6. So where is the strong correlation? Strong correlation is 1 and 3. But 1 is strong positive, 3 is strong negative. So these are our CTPs. These are the critical to process. These are our CTPs. So let's do one exercise. You will see here on page 65. We have the data. Your exercises draw a scatter plot for the following data. So you can take a plain paper and put the readings on the graph and join the dots with a scale with a straight line in such a way that some point will be touching the dot, some point will be above or below the dots, below the line. So this kind of line is called as a best fitting line. So just you can draw now. Just tell me one thing. Here we are comparing kilometer per liter with weight. So what you will put on y-axis and what you will put on x-axis. I told you dependent variable goes on y-axis.
Kilometer per liter will go in the y.
Absolutely right, because kilometer per liter will depend on the weight. So kilometer per liter will go on y-axis and weight will go on x-axis. So please draw these points and give me your interpretation about the correlation. Is it a strong correlation? Is it a medium correlation? Is it weak correlation? Is it strong positive? Is it medium negative? So give me your, draw the graph and then give me your interpretation of the graph. This is on page 65. The last page. एक्शन पे हमने लेगा बाकी वो डिस्क्रिप्टिव स्टैट्स तो फिर ना होगा मीन मीडियन वो हाँ तो वो तो फिर वो बैठना होगा ना। सवेरे उठ जब वो करता रहते हैं तो सुनते रहे ना कि सारा बहुत सारे पाले चिराग भी your correlation diagram or scatter plot will look something like this. Is it right?
Yes, yes. This is negative moderate correlation, something like this.
This is strong. Actually, most of these
Negative
points,
strong. Okay.
yeah, points are near the straight line. So this is a strong,
Strong. Okay. Yes. Negative.
strong negative. As the weight will increase, what will happen to the kilometer per liter?
Reduced. Reduced.
It will reduce. That is the weight. That is why if you reduce the weight, kilometer per liter will increase. That is why the car manufacturers are trying to replace steel parts with fiber parts to reduce the weight of the car and increase the kilometer per liter. Now, sometimes, like in this example, you are not very sure whether you can say that this is a strong correlation or a medium correlation. So for that, there is another method. We can also calculate the correlation. That is called as a correlation coefficient, and it is written as R. So we will go to Excel with the same exercise, and I will show you how to draw this graph in Excel and how to calculate the correlation coefficient. So please go to your data sets again. And in the data set, you go to the second tab, car weight fuel. The same exercise here. So you have the weight of the car, the name of the car, the weight of the car, and the kilometer.
Can you share your screen, please? Can you share your screen?
You have the name of the car, the weight of the car, and kilometer per liter. Now, we will select weight and kilometer per liter, these two columns, just like we did for Pareto and histogram. For Pareto, we did same thing. So, weight and kilometer per liter, we will select. And again, we will go to insert on top, recommended charts. And here in recommended charts, you will see scatter. You click on scatter and OK. So your scatter plot is done. Again, you click on this plus sign, chart elements, and tick mark the labels and the trend line. So now you've got the scatter diagram in the Excel. What you did manually, same you've got in the Excel. And this is showing the same, that as the weight will increase, the kilometer per liter will go down. So you can do this in the Excel calculation. Correlation coefficient also we can calculate in Excel. So I will show that also to you. For that, we will go to the book for 2 minutes. In the book, you will see this R, correlation coefficient R. So R is calculated by using a formula. That formula is shown here on page 66. So here the calculation of R is shown. How do we interpret R? So this is, if you see this chart here, if the value of R is below 0.3, that means basically R will vary from minus 0.3 to plus 0.3. So if the value of R is minus 0.3 to plus 0.3, we will say no correlation. The value of R is 0.3 to 0.7 or minus 0.3 to minus 7. We will say weak correlation, weak, strong weak, or sorry, strong positive or strong negative. And if the correlation coefficient is 0.7 to 1, we'll say strong positive, minus 0.7 to minus 1, strong negative. This also we can conclude from the correlation coefficient. So how will we calculate this correlation coefficient? Because this looks to be a complicated formula. So we will learn that. But to do that, you will have to do one exercise with your Excel. In your Excel, you please go to this top, you go to File. Are you all there? Go to File in Excel. Click on More. Click on Export. I'm sorry. File.
Can
More.
you share your screen? Can you share your screen, please?
Please
Yeah.
share. Yeah, thank you, sir.
So you can see my screen.
Yes, yes.
Yeah. So go to File. In Excel, go to File. Come down here below to More. Then you will see here Options. Click on Options. You will see on top Excel Options. Under Excel Options, come to Add-ins and click on Add-ins. And then you will have Manage Excel Add-ins. You click on Go. Everyone got it, or should I repeat?
Okay, okay.
So now then you tick mark Analysis Toolpack and Analysis Toolpack VBA and OK it. So now we have created a function in your Excel. If you will click on Data, now you will see this Data Analytics. Normally it is there, but it is hidden. You have to activate this. These are the data analysis tools. You have to activate this. So now we have activated this. So we will calculate R with the help of this exercise. So we will select, we will go to data. Now we will go to data. Now we will not go to insert. Now we will go to data, data analysis. Go to correlation here. Next week we will also use this for descriptive statistics, but today we are using this for correlation. Okay, this. Now, input range. What is input range? This data, take the two columns together. That is the input range. So from C3 to D13. Now, you will see this titles in the first row. So you will tick mark labels in first row. Output range. Click on this arrow and select some column for output range. Momentum. We will do this again. correlation. Okay, this. We have selected this column C3 to D13. We have also selected the headers. So I selected labels in first row. And here I will select some column. So I will click here and I will select, let us say, F3. I will OK this. And now I will OK this. So now I've got the
Can
correlation
you
coefficient.
share your screen?
Sorry?
I cannot see the screen.
I'm sharing it now. Yeah. You can see the screen now.
No, we cannot see. We cannot.
You cannot see it. Let me see. Is it okay now?
Yes.
Yes, yes.
Okay. So we'll do this again. We will go to data. From data, we will go to this data analysis. Select correlation. Okay, this. We already selected this column C3 to D13. Labels in first row. Why? Because we are selecting with the header. Output range. We are saying we will take the output here. One minute. What is happening in this? Let me try once again. We'll do this again. So we are taking this data analysis, correlation. Okay, this. We are selecting these two columns, B and C. Sorry, C and D. C3 to D13. Then labels in first row, output range. We have selected here. I'll do that again. So let us say we have selected output range here. Okay, this. Now we got the correlation coefficient. This correlation coefficient, this is coming to how much? Minus 0.966. So how will you interpret this? I
Not
should,
for
Showing
negative.
strong negative correlation.
yeah, it is a strong negative correlation. As I've shown you here earlier, here the value of R is between minus 0.7 to minus 1. It is 0.966, so which is very strong negative correlation. So you can find this correlation. By finding the CTPs, we can find many solutions because we can make changes to the CTPs and that will have an effect on improving the CTQs. But before doing that, we have to do this scatter plot or correlation diagram to establish that the axes which we are taking for CTP are correct. Then we will focus on improving those axes, the CTPs, and we will be able to show that how much improvement we are making in the Y because of changes in the X. So here we have covered 6 tools of quality. If you see on page 67, summary. So flowchart, process map, check sheet, Pareto chart, histogram, fishbone, scatter. These 6 we have covered. This one we have not covered. Control chart SPC, this we will cover in chapter 11. So one more homework for you is you have to read this page 67. Every tool we have explained the purpose. What is the purpose of this tool? And you will use it for which data. These tools are like the tools in the bag of a carpenter. The carpenter must know purpose of each tool. If he tries to hammer a nail with a screwdriver, he will not get any success. So you must know purpose of each tool. So that is what is explained on this page 67. For example, flowchart process map, what is the purpose? It makes the process steps visible. It helps us to do the value analysis, add appraisal prevention, look for missing steps. Check sheet, it is a data recording device. We can use it for attribute data or count data. We can't use it for variable data because it's not a measurement, it's numbers. Pareto chart, wherever you have to do priority, you will use Pareto chart. Vital few, trivial many. You can use this for count data, like we did for railway accidents. You can do it for variable data, like we did for value of rejections of the supplier. Histogram is used for the variable data. Again, that is shown here. Used for variable data. It shows how the data is spread out. And later on, we will learn histogram. What is this mean, median, mode? Also, histogram shows the range of the data, how much it is spread out. So that is the purpose of the histogram. Fishbone, the purpose is brainstorming. After brainstorming, you do the Pareto, find the vital few root causes, then do the root cause analysis. Scatter diagram, you are using, also called as correlation diagram. You are using this for finding the CTPs so that you can take action to improve the CTPs and achieve the CTQs. So we will stop here today. There are 3 homeworks. Will someone repeat the 3 homeworks?
What did you say, please?
I said there are 3 homeworks I have given you. So can you repeat what are the 3 homeworks? So I told you to
What
read.
Is
Told you
chapter
to
8
read
181.
to read the chapter 8.
chapter 8. You have to read cultural changes required while implementing Six Sigma. Then I've told you to read the article on AI applications in Six Sigma, 180 to 200.
Yes, sir.
And just now I've told you to read this page 67.
7. Yes.
Yeah.
Yes, sir.
So we will stop here. There is a quiz on these tools, but we will start with that in the next session. So anyone, any question you can ask. Otherwise, I am stopping here for today.
Thank you. No question.
Okay. So
Thank
good
you,
night
sir.
to all of you. Have a good week ahead. Do complete your reading before you come on next Friday.
Thank you very much. Thank you.
Thank you.
Thank you, sir.
Thank you. Bye-bye.
Bye-bye. Bye.
समझे?